Lesson 02. Use problem-solving strategies and models. The United States uses degrees Fahrenheit for temperature. Most of the rest of the world uses degrees Celsius. So if you're traveling from the United States to another country, or reading about a heat wave in another country, you need a formula to convert between Fahrenheit and Celsius. That's the type of thing we'll look at today. Here are some common formulas. You should memorize them. We have distance equals rate times time. Distance is rate times time. Or a temperature, Fahrenheit, is 9/5 Celsius plus 32. Area of a triangle is 1/2 base times height. Remember, the base times height must be perpendicular. Area of a rectangle is length times width, or base times height. That's what we did in geometry. Perimeter of a rectangle is 2 lengths plus 2 widths. Area of a trapezoid. Remember, trapezoids are something like that. The top and bottom are parallel. That's base 1 and base 2, and then the height is perpendicular to those two bases. So it's 1/2 base 1 plus base 2 times the height. Area of a circle is pi r squared, and the circumference of a circle is 2 pi r. Now, the easiest way to solve a word problem is to start by writing an equation in words. It's called the verbal model. You think, oh, yuck, but you probably already think this way in your head. And I think most people actually think in words in their head. So, yeah, you think, oh, hey, it's distance equals rate times time. Oh, that's one way to find the verbal model, is use a formula. Last slide just had a whole list of formulas. Or you could look for a pattern. Oh, it looks like it's decreasing 2 with every second. Or draw a diagram. It's okay to draw pictures. It's good to show your work, to see your thinking. It helps you to think. An Arctic tern flies an average speed of 16.7 miles per hour. See, it's a bird, like in the picture. How long will it take to fly from its winter grounds in Antarctica to its breeding grounds in Greenland, a distance of 12,000 miles? So they fly all the way from almost the South Pole to the North Pole and back every year. So do you think this would be easier to come up with our verbal model with a formula, a pattern, or a picture? Yeah, I think a formula. So this sounds like it's a distance equals rate times time. Why? Because I have distance. That's a rate. And we're looking for time. So distance equals rate times time seems to be pretty good. So our distance is 12,000 miles. Our rate is 16.7 miles per hour. And we're looking for our time. So we could divide by the t, divide by the 16.7 to get the t by itself. Make sure you do that to both sides. So 12,000 divided by 16.7 is approximately 719. But what's our units? Well, the miles canceled out, so it's hours. It's a lot of hours. What if we converted that to days? There's 24 hours in a day. If you divided it by 24, you get 29.9 days. Now that's flying non-stop at that speed. Bet you they probably go faster and then rest. But still, it takes a month for them to fly that far. Let's try a problem about paramotoring. So it's this guy who straps a big fan to his back and has this like parasail parachute wing thing, and he flies around with that. The table shows the height of a paramotorist after t minutes. Find the height of the paramotorist after 8 minutes. Well, formula, pattern, or picture. See the table? That's probably going to indicate a pattern. So it looks like every minute, if I subtract these, yeah, he's going down 210 feet. There, subtract that. Oh, it's down 210 feet. Subtract those. Oh, it's down 210 feet. Subtract those. Oh, so he's dropping 210 feet. All right, so let's get a verbal model. What would be our height? Our height would be our, let's call it our initial height. That's where we started at. Minus the 210 feet per minute times the number of minutes. What we're looking for, height, let's call it h. Our initial height is here, 2,400 feet, minus the 210 times time. Oh, wait, we know our time is 8 minutes, so let's put in the 8 and run that through a calculator, or do it in your head if you like, and you get 720 feet. So he's still a good distance above the ground, not ready to crash yet. A bear walks 10 miles towards the west. Then it turns around and walks east for 2 miles to try to catch a fish because it's hungry. After lunch, it walks 5 more miles west until it finds a place to sleep. How far is the bear's sleeping location from its starting position? Think you want a formula, a pattern, or a picture? Well, let's probably do a picture. Okay, so we're going to start here. And remember, it's north, south, east, and west. Never eat spider webs. You have to remember. All right, we're 10 miles west. So we go this way 10 miles. Walks east for 2 miles. And then 5 more miles towards the west. All right, so that's where we end up, right there. So maybe what we could do is count everything left, negative, because that's usually what it is, and everything right, positive. So it's negative 10, but then we went to the right 2, then negative 5. So I'm going to count west as negative, east as positive. So what's that give us? That gives us negative 13 miles. Or if you'd like, 13 miles to the west from where you started.